Welcome to the Interval 0 video overview of subsystem monitoring, the monitor utility and Tracealyzer for RTX64. In this video, we provide a high-level look at how you can analyze the runtime behavior of your real-time applications in Tracealyzer using monitoring session output provided by the RTX64 Monitor utility. The monitoring functionality in RTX64 allows you to trace the behavior of your real-time applications by recording significant events that occur during execution of those applications. Using the RTX64 control panel and RTX64 Monitor utility, you can choose the events you want to collect, filtering out the events you're not interested in. You can then view and analyze session data using the Tracealyzer tool discussed later in this video. Monitor events belong to two distinct sets, the persistent event set and the transient event set. The selection of events in the RTX64 control panel is persistent, which means it applies to all future monitor sessions. Each time the RTX64 subsystem starts, the persistent event set becomes the set of enabled monitoring events. When monitoring is enabled, a transient event set is initialized from the persistent event set. You can modify the transient event set using the RTX64 Monitor utility. Changes to the transient event set do not affect the persistent event set. When monitoring is disabled, the transient event set is destroyed. Since monitoring of data impacts real-time performance, monitoring is turned off by default. We can turn it on in the RTX64 control panel on the Change Monitoring Settings page. Here we can also choose the default set of events to collect, specify session collection behavior, configure session logging, and determine how monitoring behaves when certain stop conditions occur. Under Configure Events to Collect by default, you can manually choose events to collect or select one of the predefined sets of events, such as Collect Memory Events, to only collect events specific to that area of focus. The number of events selected for collection will determine the internal memory needed by RTX64 monitoring. If you are logging a large number of frequent events, you may need to increase the memory used by monitoring. You can do this on the Manage Memory page in the RTX64 control panel when monitoring is enabled. If you do not have enough memory, you will see a data lost event when you view your monitoring results. This indicates the internal monitoring buffers did not have enough space to log data as it was being generated. Under Customize Session Collection Behavior, you can configure the maximum number of events to collect in a monitor session. Optionally, you can specify the number of pre-start trigger events to save. Pre-start trigger events are events that occur before the event that triggers the start of a monitoring session. Under Customize Session Logging, you can specify where session logs are saved and set a maximum value in megabytes for the size of a single monitoring session folder, as well as the maximum disk space allowed for all monitoring session folders. RTX64 displays a warning message when the log folder size might exceed the available disk space on the system, when the monitoring log folder is nearly full, or when the maximum session log size on disk value exceeds the maximum disk space allowed value. Under Customize Session Logging, you can also configure how monitoring behaves when the event count, session, or disk size is reached. For these conditions, you can choose to stop collecting events automatically or continue by discarding older events until monitoring is stopped. Once monitoring is enabled in the RTX64 control panel, you can use RTX64 Monitor to change the events selected for collection, set triggers to start and/or stop a monitoring session, dynamically start, stop, and pause monitoring, and configure session options. You can open the RTX64 Monitor utility from the Start menu or the Change Monitoring Settings page in the RTX64 control panel. RTX64 Monitor consists of two pages. On the Events and Session Triggers page, you can view the current monitoring status, customize the list of events to collect in a monitor session, create start and/or stop triggers from events selected for collection, and dynamically start, pause, or stop a monitoring session. Under Choose Events to Collect, you can toggle selection of events to include or exclude single events or group of events from the monitor session. This is the transient event set discussed earlier in this video. Changes made here apply to all future monitoring sessions until monitoring is disabled. You can associate monitor events with session triggers to start and/or stop event collection automatically. To create a start trigger for an event, drag that event into the Start Trigger section. To create start triggers for all events in a group, drag the top-level group name into the Start Trigger section. To create a stop trigger for an event, drag that event into the Stop Trigger section. RTX64 allows you to create custom events programmatically through the RT-Generate Event API. You can create session triggers for all custom events or for a single custom event ID. To create session triggers for all custom events, drag the custom event group name into a trigger section. To create a session trigger for a single custom event ID, drag the Drag to Create Trigger by Custom ID tree node into a trigger section and then enter the custom ID of the custom event. The custom ID corresponds with the parameter kind in the RT-Generate Event API. See the tooltips or RTX64 help for more information. In order for triggers to take effect, you must click the Set Triggers button to apply them. Note that once a session is started, start triggers are no longer set. On the Session Options page, you can override default control panel settings and set a maximum number of events to collect in a session, and optionally collect a certain number of pre-start trigger events in a session. Convert monitoring data from a monitor session file to a readable text log file, and delete session folders. Note that you can't delete an active session folder. Next, we'll look at a simple RTSS application that we'll include in a monitoring session and later analyze in Tracealyzer. For this video, I'm using the ping-pong sample application. Looking at the code, we can see two threads that use an event to signal between one another. Later, we can look for this event in Tracealyzer. Tracealyzer is a diagnostic tool for software systems based on RTX64. It was created by Percepio and is provided as part of the RTX64 SDK. With Tracealyzer, you can analyze subsystem and application behavior from monitoring session output to see if your application is behaving as expected, or if application elements require optimization. Tracealyzer provides a visual representation of the events that occur during a monitoring session. When a monitoring session file is opened, Tracealyzer displays the full high-level view of the session in the Trace view. Trace view displays all recorded information on either a vertical or horizontal timeline. Each core has its own timeline. Cores on which there is no activity do not appear. Tracealyzer provides more than 30 interlinked views of application behavior, including scheduling and timing, interrupts, and interactions between threads and user events generated from your application. Tracealyzer can be used side by side with traditional debugging tools and complements the debugger view with a higher-level perspective, which is ideal for understanding more complex errors such as race conditions that cannot be analyzed through a typical debugging session. You can access the most frequently used views from the navigation bar, the vertical icon bar located at the left edge of the Tracealyzer UI by default. The initial high-level view is typically too broad to provide a useful view of the data you're interested in. You can use Tracealyzer's zooming and navigating options to target a specific area of the session data to analyze. There are several ways you can zoom in and out of the display. Here we'll use the Control key plus the mouse wheel to target specific session activity. Tracealyzer uses two key concepts: actors and actor instances. An actor is a thread. Actors are represented by vertical bars of varying colors based on thread priority. An actor instance is an execution of an actor. This is the set of all fragments connected by the same colored band. It represents a single execution of the task which the thread performs. Click on a thread to view its information in the Instance Details window. There you can see all of the instances that are related to the selected thread, as well as thread-specific details such as start and end time, execution time, and response time. This information is also available from the Selection Details view, which displays information about the currently selected actor in the main view. We can filter for certain threads in the filter view. For instance, if I wanted to focus only on the ping and pong threads from the sample code we looked at earlier, I would filter the actors such that only those instances are shown. The events belonging to a thread are displayed as text labels in the trace view. The color of the label indicates the event type. One such event type is raw events, which are detailed low-level monitoring events that contain data from the RTSS subsystem. It can be beneficial to show these events as they contain additional data that Tracealyzer normally abstracts away, such as low-level handles and pointers. By default, raw events appear as teal text labels. The text in a raw event matches the user-readable textual output from the RTX64 Monitor utility. By default, raw monitoring framework events are included in the trace. However, in order to see these events in the trace view, you must turn on their display in the filter view. It is important to note that including raw events may significantly increase memory usage, as well as the time it takes for Tracealyzer to load. It also causes a duplication of events, as you end up with both the raw event and the kernel event. Custom events are another event type you will likely want to see in Tracealyzer. Custom events are generated by the function RTGenerateEvent and are displayed as user events in Tracealyzer. By default, custom events appear as yellow text labels. Custom events are not shown in the trace view by default. You'll need to turn on their display through the filter view in order to see them. This concludes our overview of monitoring and Tracealyzer. For more information, see the product documentation installed with the RTX64 SDK and available online at intervalzero.com. Thanks for watching!